Engineering, NIT Sikkim, warmly roll down the red carpet of welcome to all the dignitaries on this remarkable day of the year. Thank you for taking out time and being here today. India has a great heritage of science and technology. From the ancient medical experts have contributed their work to the progression of science and technology, and India is rapidly progressing to reach the peaks of science and technology in the world. We celebrate the National Science Day to appreciate the efforts of individuals and organizations who are working to make India reach the peaks of science and technology and the lives of people better with the help of science and the emerging technologies. Today, on this great National Science Day, let us pledge that we do our bit to make science and technology better every coming day, and we will use the technology to make the life of the people simpler. Now, I request Honorable Director Sir to kindly address the gathering with his kind words as we start the event. Please, sir.
Good evening to all of you. First of all, I would like to welcome our Honorable Chief Guest, Padam Shri, Professor Shankar Pal, Ex-Director, ISI Calcutta. All the esteemed professor, the entire fraternity of the student, dear students, participants, and ladies and gentlemen. First of all, I would once again pay my gratitude to Professor Shankar Pal being ready for delivering the keynote address on this very important day. It is a great pleasure to talk on this mesmerizing occasion of National Science Day 2021. Every one of us know National Science Day is celebrated every year on 28th February since the last 3 decades in order to commemorate the discovery of Raman effect in India by Indian physicist Sir C.V. Raman. The main objective of the Science Day is bring awareness to people about importance of science in our daily life and to encourage the people to popularize the use of science and technology in day-to-day activities. This National Science Day becomes more prominent with the declaration of our Honorable Prime Minister, the Atmanirbhar Bharat, where every one of us, especially the institution like NITs, IIT, has to deliver a great deal to make each and everything indigenous. And I think Sir C.V. Raman reminds us our duties and responsibilities to with this great nation. This year, the theme of the National Science Day 2021 is Future of Science, Technology and Innovation, Impact on Education, Skill and Work. The National Science Day celebrates science and technology and its feasibility in our everyday life. It also promotes scientists, researchers, students, and those interested in promotion of science and technology. Every year, we must observe the day with the same vigilance and integrity. It should not be restricted solely to the brotherhood of scientists, but must also include members from all walks of life. The very significant eponym of the day lies within the glorious name of C.V. Raman. At the mere age of 35, he discovered the famous Raman effect. The effect itself presented and explanation about the sea having the blue color. The principal feature of that is that when matter is excited by light of one color, the atom contains in it emits light of two colors, one of which is different from the exciting color and is lower down the spectrum. The astonishing thing is that the altered color is quite independent of the nature of the substance used. Depending on these certainties and wavelength, the light changes color into all the beautiful spectrum we have seen from our eyes. Treasuring all those past discoveries, we feel intensified with the pride to mention the successful news about the perseverance who has finally able to have touchdown on the planet Mars. It was launched in mid 2020s and marvel of science, maths and engineering showed we cannot only survive here on the earth, but we are capable enough that we could make a machine that could autonomously drive its path through the alien planet like Mars. It is known as the miracle that we have come so far. And I hope with more advancement and innovation, we will keep moving forward to revolutionize our lives and this world. I also being get reminded on this occasion that the indigenous vaccine has been made by the India for this pandemic COVID-19, and I think this is another milestone which is being added to the feather of this great nation. And I believe our young scientists and engineers as well as the physicists will do great things to make the dream of our nation never a reality, and we all are together to work very hard to take this nation forward. With this, I thank each and every one of you being present here on this very important occasion to remind our duty towards this nation. I once again thank the Professor Shankar Palji for being present here and guide us as well as the young generation of this institute as well as the participants joining from other part of the India about their duties and what will be the future of this science and technology. Thank you. Jai Hind.
Thank you, sir, for your kind words. Now, I would like to introduce to our audience our chief guest for the occasion. Professor Shankar K. Pal is a renowned scientist and former director of Indian Statistical Institute. He founded the Machine Intelligence Unit and the Center for Soft Computing Research at ISI Calcutta. He received a PhD in radio physics and electronics from Indian Statistical Institute, University of Calcutta in the year 1979, and another PhD in electrical engineering along with DIT from Imperial College, University of London in the year 1982. He joined Indian Statistical Institute in the year 1975 as a CSIR Senior Research Fellow, where he became a full professor in the year 1987, distinguished scientist in the year 1998, and the director for the term 2005 to 2010. He is currently a National Science Chair and ISI Emeritus Professor working at ISI Calcutta. He is also a scholar in residence of IIT Jodhpur. Professor Pal worked at the University of California, Berkeley, and the University of Maryland, College Park, the NASA Johnson Space Center, Austin, Texas, and in U.S. Naval Research Laboratory, Washington, D.C. He has been a distinguished visitor of IEEE Computer Society USA for the Asia Pacific region and held several visiting positions in Italy, Poland, Hong Kong, and Australian universities. He is a co-author of 20 books and more than 400 research publications. Professor Pal is a Life Fellow of the IEEE and Fellow of the World Academy of Sciences, International Association for Pattern Recognition, International Association of Fuzzy Systems, International Rough Set Society, and all the four national academies for science and engineering in India. He visited 45 countries as a keynote speaker and as an academic visitor. He received the 1990 S.S. Bhatnagar Prize 2013 Padma Shri by the President of India and many prestigious awards in India and abroad. The presence of such a personality is a blessing for us. We hope that the students are able to seek guidance and imbibe knowledge from his thoughts. I request Sir to enlighten the audience with his precious words. Please, sir.
Sir,
Yeah.
yes, we are we are eager to listen from you, sir. Now.
Okay. Thank you, because I thought actually suddenly it has stopped. Good afternoon. It's my great pleasure to be here on in a virtual platform to deliver a lecture on National Science Day, and I thank the director in IT Sikkim, Professor M.C. Gopi, and the other organizers for inviting me. It may be recalled that last year on the same day, we were all again in Sikkim. At that time, Professor Gobil delivered the National Science Day lecture in the afternoon. So 1 year has passed, and most of us, we could not travel much, practically zero for me. And I like the name Anuvrat. It's a beautiful name you have given. The talk I have presented, could you please?
Sir, present now option will be there. Achal, Sony, please.
Yes, sir. Yes, sir.
Yeah.
There is no.
Yeah, just a minute, sir. Yes.
Yeah.
Yes, sir. Now.
So you can present now.
Yes.
Yeah, present now. I can present now. Your entire screen.
It will be at the bottom right side.
Can you
Bottom
just
right at the right side. Present now option will be there.
Yes.
Sir, you have to click it.
Yes, I clicked it.
Then select window option.
So window option, okay.
Yes, sir.
Then share, right?
Presentation, sir. You have to select the presentation and then
No, it's not.
you can also select the entire screen. Then, sir, आपने presentation open किया है?
Yes.
Is it open? Okay. Now,
Yes.
if you click window option, then that presentation option will be there in the window.
Just a minute. I'm not getting it. Why not? Present option, when I click it, it comes to share and cancel. That's all. Age ones, share an application.
Sir, presentation open नहीं हुआ है, उसका मतलब है.
Present option, then I get 3 options, your entire screen, a window and a tab. So I click a window, right?
Your entire screen. You may also select your entire screen. तो उसमें से भी हो जाएगा.
Yes, I selected the screen, entire screen. Then it comes share your entire screen.
Double click. You have to.
No. He wants to share the content of your screen.
Otherwise, you can mail us also. We can share it from our end.
Sorry?
So it's very simple. So first, open the presentation on your machine, on your laptop or desktop. Keep the presentation open.
Yes, presentation is open.
Yes, sir. After that, sir, kindly click on the browser that you are using, maybe Chrome or Mozilla, and reach the Google Meet page. By clicking on the browser, go to the Google Meet page. Once the Google Meet page is now open, there click on the present now option at the bottom right hand side.
I don't know what to talk. Huh? Slide.
थोड़ा समझ लीजिए.
I'm using the Microsoft browser.
All right, sir. So
Meet,
it's very simple.
there is called Meet Google.
Yes, sir. Now, so on the Google Meet page, in the bottom, on the right hand side, there is a present now.
Google Meet page.
Yes, sir. The Google Meet, which is an interactive page on which you can see the window carrying the photo and name of all people.
Yes.
Yes, sir. Now, on the bottom of that window, you see there is a present now option. Right hand side, present now option.
No, I'm not seeing it. That's why. I see that is a share and cancel. That's all.
All right, sir. Sir, can you see all of us in that window?
Yes,
Conference.
yes.
All right, sir. So on that very page, sir, at the bottom right hand side, there is a present now option. Bottom right hand side, there is a present now option. On the corner of the right hand side, bottom.
Present now option was there, yes, before.
Yes, sir.
Just a minute. Present now option, yes. Yes, I clicked it and then I see that three options, your entire screen, a window and a tab. I told you.
So kindly select a window. Kindly select a window. The moment you will select a window.
Yes.
Sir,
now I get this.
Yes, sir. Now there will be 2-3 pop-up windows together simultaneously. Out of those two windows, kindly select the window in which your presentation is visible.
Yes, I have selected it and then I share. It comes share.
Yes, sir. Share it, sir.
Now it's okay?
It will take some time, sir. Yes.
Yes, sir. Yes, sir. It is okay.
Okay. Thank you very much. This is the problem. Is it okay now? Can you see? Huh?
Yes, sir. We can see it.
Should I start now?
Sir, please.
Okay. This is about 1 hour talk, I was told. Now, it's a science day lecture, but since you are in the National Institute of Technology, one thing you should remember always, my dear friends, students, that if you do not have good science, you cannot have good technology. So no good science, no good technology. So you cannot segregate these two. This you always keep in mind because you are doing engineering. Without understanding the science behind, engineering cannot be developed. Now today I will be delivering a talk on our forefront research areas in the country because you know that our Prime Minister Sri Narendra Modi ji, he has been telling for the last couple of years about artificial intelligence and machine learning in our country as a key tool for Atmanirbhar Bharat. And also this is linked with this Make in India slogan that we have been having for several years. Now, my talk will be granular data mining in video analytics. That is given a video how to mine the information, and it has got wide applications from surveillance to security, etc., etc. Now, my highlight will be towards shallow learning to deep learning. So this is a buzzword all of you must be hearing for more than a year or so in India. Deep learning. So this will be my talk, and my talk has no mathematics practically, just concept. And so if you have listened to me last year, you have seen that similar. I do not use usually in mathematics unless you ask the question, and it is highly interdisciplinary. Granular computing, data mining, you have to understand video, then you have to understand machine learning, then deep learning. And of course, in the process, the artificial neural networks. And now I'm working as a National Science Chair of the Government of India since August 2020. This will be my presentation. I will explain the components of granular computing. It is subject of about 10 years old. And we are developing in India, we are the first group of scientists developing this technology. There are a couple others in Canada, US, and Europe. So I will explain granulation, granules. Then I will explain the role of rough set theory, which was explained by a mathematician, applied mathematician from Poland, Warsaw. He has passed away 4 years back. Then the concept of generalized rough set theory, just one slide to keep a parity because they are uncertainty modeling. Because when you have a data, uncertainty is inherent. Whether it is a small data or it is a medium-sized data or it is a big data. Then I will take this portion and I will explain the significance of lower and upper approximation of rough set for video analytics, the new concept of granular program, new concept of rough filter, being an electrical and electronics communication student, you have heard about filter, but you haven't heard about then granulated deep learning, and at last, challenging issues. That's most important thing. Because as a researcher, you must understand in front of you what are the challenging issues. If you read the books, you may not understand. If you read the current books, then you will see what is the present status. But it will be very easily difficult to find the challenging issues unless you start working. So I will be spending in the last part that portion. What is granulation? Is basically natural clustering. That means when you see at a scene, what you see some water body, some vegetation, some sky, some roads, etc. When I give a lecture in an auditorium, what I see? Some young people, some girls, some old people, middle people, and so on. So this is a natural clustering. I do not look at the individual picture element, or I do not look at the individual persons who are listening to me. So basically it's replacing a fine-grained universe. Universe is fine-grained, but we are making it replacing it by a coarse-grained in terms of clustering. And more we like of human perception. That's how human perception works. We always look at the problem from the point of coarse-grained, natural clustering. So it is a process of like self-organization, self-production, morphogenesis, Darwinian evolution, which are abstracted from natural. So these are all natural phenomena. And from those, we derive the technology. And granular computing is one such technology which has been organized from granulation. And granulation is a natural process of human perception. And in the process of natural clustering, we form clusters, segments, and these are called granules. So granules are nothing but the outcome of granulation, natural clustering. So it is a process for formation and representation of granules. So these are the tasks. So given a granulation task, what is the process of forming the granules and representation of the granules? That's the challenging areas. Example, the concept of granules. So mathematically, we can say it's a clump of indiscernible, that means indistinguishable entities with respect to given attributes. And concept of indistinguishable or indistinguishable, they are meant for with respect to say some property like similarity, proximity, functionality. When you are considering a genome data, gene data, RNA data, then you go by the similarity in terms of functionality. When I look at a vector space, we measure the similarity in terms of proximity, but by distance, and sometimes the angle. So it's a clump of indiscernible entities drawn together by some properties like similarity, proximity, or functionality, or something else with respect to given attributes. If you change the number of attributes or features, then this definition will be changed. That means granules can only change. Example, age. When we consider age, very young, not so old, they are called granules. Because we do not look at whether the boy or girl is 24 or 25 or 27 or 30. We look at the one and say, yeah, very young. Oh, okay, young, not so old. So this is a good granule. That we do not consider individually the fineness. We go by the coarse definition. So when we drive a car, we use the concept of slightly left, slightly right. We do not go by the measurement. Similarly, in a school, each class or section can be called as a granule because those section is determined either by the marks obtained in the previous class or by age group or by sex. Similarly, in image, gray image, if you look at here, we have got 6 consecutive gray levels. 1 to 6, 2 to 7, 3 to 8, etc. And as per Weber's law, our naked eye cannot discriminate. So I can consider regions of similar colors, regions of similar gray values as granule. Now, if you look at this, here this granule have crisp boundaries, class. Here also granules have crisp boundary, 1 to 6, 2 to 7. But here, these granules, they do not have crisp boundary. It's a fuzzy. So the granules may be crisp, granules may be fuzzy. So I am explaining so that in your real life problem, when we take our one, granules to be either crisp, to be fuzzy. And obviously, according to the technology, will be different. So granular computing is basically a twofold task. It's a information processing paradigm that works with the process of information granulation or abstraction. And where the computation is performed using information granules, not the data points or objects. That means you forget about data points, individual data points. You extract some information or you abstract some quantitative information, qualitative information. This is called granule formation, and you play with this granule, not with the individual data points. And since granules or information granules are nothing but compressed information that we have derived from the data. So there is a possibility called computation gain. And therefore, it will be suitable for mining large data sets. That was the basic philosophy behind me or my group when we started working in this area about a decade back. That because that time data mining was a buzzword and there was a problem of handling big data, processing with big data size, so suitable for mining large data. And in most of the cases, we do not want a precise solution. Most of the cases, we want a coarse solution. So in summary, granular computing is a nature-inspired information processing paradigm with the basic element called granules. Granules are a collection of indistinguishable objects drawn together in terms of their similarity, functionality, proximity, etc. And granules evolve in the process of abstraction, derivation of knowledge from data. These 3 steps are very important. It's a nature-inspired information processing paradigm with the basic element called granules. Granules evolve in the process of abstraction and derivation. So granules could be adaptive process. And granules are nothing but mathematical collection of indistinguishable objects. So having this granulated domain, we define a set. Just like in a school, there is an image, we have granular domain, I define a set. Just like in the image, when you discretize this x-axis, y-axis, and in the intensity level, you form granules. When we do not discretize anything, but the granules have those gray scale. Gray scales do not have well-defined boundary, so that goes there. It resembles the concept of fuzzy set theory. But whenever we discretize it in x-axis, y-axis, and z-axis, then we form the granule. So define the ground set on this domain. We approximate this set using granules, but granules are nothing but clusters. So I cannot make uniquely this approximation. So I approximate roughly in terms of granule from inner side, outer side, or from below or above. And this approximation of this clip set over the granulated domain in terms of granules, that gives rise to the concept of rough set. So set is crisp, but description is rough. That's why it's called rough set. Yes, set is not rough. And that was explained in 1982. For example, this is my information system. X-axis, Y-axis. These are my granules. Granules are unequal size. For example, in a school, different sections could be granule. Now, this granule, that means here all elements cannot be discriminated with respect to some relation. And that is the relation with respect to feature set B. Now, given this granulated domain, this is my crisp set X, and I approximate this set from inner side. That means these are the granules which definitely belong to this set. And I approximate the set from upper side. That means these are the granules which definitely as well as possibly belong, because these are the granules, they do not definitely. So we have a granule definitely belonging as marked by yellow line. I call it lower approximation. That means they definitely belong to this concept, to the set, to the region, whatever you say. And there is another set which also includes the previous set, where granules are definitely belonging as well as possibly belonging. And if I take upper approximation granules, subtract lower approximation granules, I get this boundary granules, which are the possibly belonging granules. And these possibly belonging granules, they create problem. They create ambiguity. They create uncertainty. So when I have a granulated domain, even I define a crisp object, crisp concept, crisp shape that can be approximated only in terms of lower and upper approximation, approximately. And this vague definition of this set in terms of granules, the vague definition of set in terms of this granule is called rough set. So rough set means granules definitely belong to X, granules definitely and possibly belong. And when X upper equal to lower, I call it exact set. That the upper equal to lower means there is no granule. Upper equal to lower means there is no granule. So granularity comes only because of this, the upper and lower comes only because of this granularity. And if lower equal to upper, set is called exact. There is no granularity, there is no uncertainty. And B is definable. Otherwise, it is roughly definable. And again, rough sets are crisp set, but with rough description. Now, this rough sets, this vague definition of this crisp set X in the universe in terms of order approximation, it signifies the incompleteness of knowledge about you. This is a very important line. This vague definition of the crisp concept, crisp set, crisp vision in the universe in terms of lower and upper approximation because of the granularity signifies the incompleteness of knowledge about you. And if we want to make a decision, we always try to minimize this incompleteness. So that's why whatever uncertainty measure we define about this rough set theory in terms of lower and upper, we always try to minimize. And this lower and upper, since they are not equal, that is creating problem. Had they been equal, there was no granularity, there is no ambiguity. So when I was working at NASA back in 1992, that time I was listening talks from East European scientists. They used to come for internship. I don't know how many of you know, NASA not only does research in space related matter, but also they fund to industry, university and colleges. So they used to come, and that time I was listening. I had knowledge about pattern recognition image processing, but then we see that it has two applications. One is uncertainty handling using lower and upper approximation. And that time, expert system was a buzzword in 80s, 80, right? Lots of experts, because every 10 years there is a buzzword comes from America mostly, and we all follow. And expert system design where experts' knowledge cannot be encoded correctly in rule base or in a knowledge base. They are using the concept of lower upper. And another is granular computing using information granules for performing computation. So let me now explain these two concepts for future application. So what is lower and upper approximation and uncertain modeling in machine learning concept? So machine learning concept, this is this is my cluster. Now I know that in a class, points around the centroid, they definitely belong. That means their degree of belonging to the cluster is most. Whereas the samples falling in the boundary, they are most ambiguous. So in the notion of rough set theory, I can say this is my code region and this is my doubtful region. Or in other words, this is my lower approximation, definitely belonging, and this is my upper minus lower. So these plus these together called upper. So given this cluster beta, I can have lower approximation, upper approximation, and boundary. And if I take the cardinality of lower, that is number of granules in lower, 1, 2, 3, 4, 5, 6, 7, 8, 9. So I get cardinality of lower, similarly cardinality of upper. And I can define, its definition was given by Professor Paulak himself, 1 minus lower cardinality of upper. That means if cardinality of lower is equal to cardinality of lower or equal to upper, that means there is no, that the lower equal to upper basically. Then 1 minus 1 will be 0 roughness. As I mentioned before, if lower equal to upper, there is no granularity, there is no roughness. Now, this was the definition as given by Professor Pavlov, but not in the sense of machine learning. Now let's come for a real life problem. There he considered crisp set, crisp granule in the definition. But in real life problem, crisp set could be fuzzy, granules could be also fuzzy. For example, in an image, see, if it is a gray tone image, you do not know what is the boundary. So, the set is fuzzy. Similarly, if you work with a 3x3 window or 5x5 window, moving over the granules, moving over the image, the 3x3 window, 5x5 window, they could be discrete or they could be overlapping. So, sets and granules can be either both or fuzzy in real life. And if one of them is fuzzy, then lower and upper approximation will be also fuzzy. And fuzzy sets are nothing but membership functions. So in that case, instead of counting the number of granules, we will be counting the membership value. We will be adding up the membership values of this granule to belong in this, membership of this granule to belong in this, and then membership value will be added up. So lower and upper approximation will be fuzzy, and accordingly we can have generalized rough set. It's called stronger model of uncertainty modeling. That means you embed fuzzy set into rough set. Fuzzy set takes care of uncertainty arising from overlapping concept, vagueness. Rough set takes care of uncertainty arising from granularity. We are not considering uncertainty arising from probability of occurrence of an event. If we consider that one, then this integration or generation will be much more powerful. So it gives us stronger model of uncertainty. Stronger in the sense, whatever you get using either fuzzy set theory or rough set theory, this integration will give you much better uncertainty handling. And here uncertainty is due to overlapping lesion and then whatever. So having this roughness in terms of fuzzy lower or fuzzy upper, or crisp lower and crisp upper. That is the ideal case. But in practical problem, it will be fuzzy. So I can define generalized rough fuzzy entropy. How we define? Suppose this is the object, then I take the complement object. So I compute the roughness of this object beta and roughness of the complement, say beta complement. And from them I can use logarithmic entropy, Shannon's exponential entropy, generalized offset. And because it's a modeling. And whatever you define uncertainty, that signifies the amount of ignorance about the system given the definition of X. Because since the definition of X is given in terms of over the granulated domain, you incur some loss of information called incompleteness of knowledge. And this incompleteness is measured or captured by different entropy measure, by integrating with fuzzy set or not, etc. And this gives rise a very good tool for decision-making problem in data. Now let's consider object tracking from video as one. You can make it simple. What is video? It's a sequence of images, sequence of image frames. So if every image has a very good segmentation, then video tracking, object tracking will be easier. Now, in case of video, you get additional information, it's called temporal information. That means difference between two frames. Obviously, if there is a moving object and if you take the difference between two frames, moving static objects, they will be nullified because there are no change in pixel element. So if you take the difference, it will be zero. Only the moving portion, after taking difference, it will give some value. So that gives a temporal information. So there are three ways. Every frame you can segment nicely, and then you see the next frame also segmentation, you can track it. Another way is that classification and estimation. So let's consider this one. This is the much more challenging task, and it is unsupervised. That I do not have any idea about the image. I have no idea about the image. So what do you do? We find some background estimation. It's a standard technique that you find estimate the background, then you subtract the background from one. That is the standard. But I say no. You model the object in terms of lower approximation. Because lower approximation means sure. So if I can have the sure amount of information, then I can expand it. So I here consider granules of arbitrary shape and size, natural granule. Tracking ambiguous situation, that means one car is moving, you are tracking, suddenly another car comes. Or different persons are moving in different directions in flow graph model I will explain, then objects are occluded. That it is moving, suddenly occluded in the crowd, suddenly occluded by pillar or by object. Still, the tracker will say, yes, this is occluded, this is not absent. And that's granulated deep learning. So these are my shallow learning. They will come learning. So granules of arbitrary shape. So natural clustering, we use RGB, red, green, blue, and depth information, that means kinetic data sets. Our granule will be three-dimensional spatio-temporal, two-dimensional spatio-color, one-dimensional color, and we form the granule by region growing. Region growing means take an image frame, take a pixel and compute its neighborhood distance in terms of similarity, in terms of color similarity. If the color similarity exceeds a threshold, then you say no, it is not in the community. So that's how you grow. So once it's grown up, then you take the next one. So that's how you make it. It's called very popular technique in machine learning, pattern recognition, image processing, region growing using color and spatial similarity of pixels. So what do we do? Granules obtained from lower approximation. So I have to find from the video frames, how to find the lower approximation of the object, and I call it object model. Then from this model, I extract granules instead of pixel. That I forget pixel. I only take a granule, and from the best of granule, I derive a rule-based granular level. then automatic updation of the rule based on program, then it can tackle information like it's unsupervised system, tackle overlapping objects, newly appeared objects from multiple objects in different direction and speed and so on. Now, what is lower approximation of the object model? Suppose the lady is doing exercise at time t. So I have t minus 1 previous frames. So I take the temporal difference, absolute difference, I get this. That means the static point, they all get subtracted. Only the moving portion. That means this is the region which I move from here to here. Then I take the t minus 2. I take the difference again. Take 3, take 2. And I'm considering in the depth space. I have RGB, let's consider this space and we have a P equal to 4. That means 3 previous frames and 1 current frame. So now I take the union intersection. I say there, this is the granule, this is the region which will be definitely belonging to this moving object, whether it is from t minus 3, t minus 2, t minus 1, 1. If you would have taken one more t minus 5, then it will be little change. So given these 4 frames, that the current frame and 3 previous frame, this is the region which will always be belonging to the moving objects. That means it will be moving, it belongs to this, it belongs to this, it belongs to this. So this is called lower approximation. That means the depth information and corresponding RGB information, they make the core point of the background. And this is my upper approximation, that means I may allow from here to here maximum to include the doubtful regions. Now we consider this, it's a depth information. Now I go to median plane and find the granule over this. Suppose this is my tau median plane, because why I take median is a more robust than mean. So in the mean point, I have extracted, this is my lower approximate region in median oil, for example. So then I make region weighing of all granules. Look at this, some granules are crisp, some granules are overlapping. Now from the representative point, so this is called spatio-color granules. That means I am computing the similarity in terms of color only. Now I go by the temporal domain from the cosine 1. And the similarity color, I get this granule, third dimension granule, third dimension granule. So this granule together with this third dimension, they constitute what's called 3-dimensional spatiotemporal granule. Now I consider only this domain and I define the set theoretic forms of this granule. And this is my tau domain, temporal domain. I can now go to the corresponding RGB. So I get RGB granule, I get temporal granule, 4 granules. So temporal domain granule, depth granule, and I get color granule RGB. So accordingly, I form some granular rule based on experience, because it is unsupervised. These are all set theoretic granules in terms of temporal domain, granules RGB, granules depth, one, and these are my arbitrary shape. This is ideal background. This is not belonging, partial belonging, complete belonging, and so on. These are all set theoretic form as defined from the granule. I forget the pixel. This is my ideal background, this is my ideal object. And here I have got 8 and 9 ambiguous. Same feature value, but different object background. So we have to make sure this unambiguous granule should not be fired much as compared to, these ambiguous rules should not be fired much as compared to unambiguous rule. If it exists, then we call it coverage factor is low, then we'll upgrade. And upgradation is made by a flow graph. What is flow graph? Flow graph maps the decision path from granular to rule base. That means how to arrive at the decision with flow graph. And once you see that some granules are more ambiguous rules are more firing, So we need to find which component is responsible, and we only modify that. That is, irrespective of doing for all the things, we only go by this particular feature which is responsible. That's why it's called intelligent updating, because it is done only for a particular feature, only when required, instead of every time. So this, look, the lady was doing exercise with her right hand, and here we do not have any program updation. And suddenly she started moving her left shoulder, the tracker is not able to track. But if you have the program updation, so tracker is able to track it because of this program updation. Similarly, so many people are working in different directions and different speed. This is a reflection of the window, and we are using only depth feature. That's why the shadow is not being tracked. Because depth doesn't change with the shadow. Depth of the shadow doesn't change. So this is one thing, and your frames per second 15 pieces. Now let's come to the question of complete overlapping, occlusion, complete occlusion. So here I use the same spatial color neighborhood granules. We define the neighborhood rough filter. What is the neighborhood rough filter? It estimates the location and color models of object in terms of lower and upper approximation. Again, sure and possibly. And based on those information on the previous p-frames, we used to model the nature of variation of the object or objects in terms of size, speed, direction, that is in terms of displacement, etc. Then we compute in the next forthcoming frame is probable estimation in terms of lower and upper. And those lower approximations we are computed from one. And if roughness, that is 1 minus cardinality of lower divided by cardinality of upper, is less, then you consider it is well tracked, you track it. If it is ambiguous, you cannot track it, that means it is occluded. Then we compute the intrinsic entropy, some kind of uncertainty measure over the boundary, that is upper minus lower, and make sure that which boundary pixels belongs to objects. Then we track it. So this measure handles partial or total occlusion. Now it is interesting. So I have T frame, T minus 1, T minus 2, T minus 3. So I take the union difference of T, T minus 1, T to T minus 2, T minus 3, T minus 4. I take the union. So union of change regions consider 1. Then again I say T to T minus 1, T minus 1 to T minus 2, T minus 2, T minus 3, T minus 1. This is completely different. First one was T to T minus 1, T to T minus 2, T minus 3, T minus 4. And here it is T to T minus 1, T minus 1, T minus 2, that is between two consecutive. So I get here one matrix and here I get P matrix, these are the P frames. Then I take a convolution, P to 1 convolution. So this is my filter input and output relation is a convolution operator. So P1 to P point convolution. And that results two output. One is lower approximation of the object model and another the upper approximation. So this 2-point approximation and convolution operator is used union and intersection. When we take the intersection, then I directly get the lower approximation. But when I take the union one, I take only those granules belonging to intersect union operation and having non-empty intersection with the lower approximation. Non-empty intersection with the lower approximation, and I call them upper. Example, this is my delta input, T to T minus 1, T to T minus 2, T minus 2, T minus 3, this is integration. I take the convolution, lower approximation object model, upper approximation of the object model. And accordingly, I define for T equal to 3, neighborhood filter, signal to noise ratio. Borrowing idea from electrical engineering. Cardinality of lower over upper minus cardinality. And obviously, cardinality obvious means this is desirable, this value should be high, and this value should be low. So it's called it amplitude of the signal, we can call it, or obvious object set, it must be higher. And this is the boundary set that are the probable noise or the download of data has. So after having this, you model the nature of variation in one frame and compute object roughness rectified linear unit. One of these tasks they do it. And in the deep learning framework, basically the object recognition means leveling different objects with the high probability classes. Or like classes are already stored because it is a supervised system. You have already trained backbone architecture, CNN. So you level, given an unknown, level the different objects with respect to probable classes and then predict their bounding boxes. Because just assigning to a particular class is not enough. You are trying to recognize. You are not making the classification. This portion is classification, leveling. And this portion are predicting their approximate bounding box. That means the guy you are recognizing or any object, what is the bounding box. And here CNN acts as the background mode to extract the features from input. That is in-depth features. CNN role is to extract in-depth feature from input to different for performing this classification, not for the bounding box, but for this classification. So CNN has been widely used for a decade. Now, this is a very simple concept. I have this CNN input, this is a convolution layer, pooling layer, ReLU, etc. So instead of considering the pixel by pixel input image, I make a granular. So instead of scanning the entire image pixel by pixel, convolution layer, we jump. So I make it for granular, spatial color granular clustering. Then I take only one, I get the mask values, and I repeat this for the entire one. I get this one, I repeat the entire value of this max pool, this convolution output. That means I slide the window only n times if there is n number of granules instead of 32 by 32 pixel, and where n is much less than 32 by 30. So there will be a significant speed up is observed, but compromising some accuracy. My question is, if you want to track, you are not interested only in finding the shape, then this is the simplest way and the best way. But if you want, then you have to think other way. So this is a very simple way of doing granulation, granulated CNN. Now, look at this one for the same laboratory image. You compute without granulation, that is the CNN model, 1.6 frames per second speed, tracking speed 82.25, accuracy of detection 70, and if you use CPU, not GPU, then granular deep learning 3x3 simple granules, very cheap granules, rectangular granules, then arbitrary shaped. Now look at this, if you make speed 2.2, input the speed, but tracking also decreasing. Let's consider this comparable. 1.6 to 1.9, 82.5, 81, 70, 62.5. And look at this speed, still you see that static objects are being recognized nicely and moving objects also. Recognition score is given under the probability of. And bring it again. It is recognizing both static object and moving object. Table chair, probability, this is the probability, high probability. Now, please ask. Now, this GDL framework we are used for only during training. We are not using for testing, just for training purpose. Sorry, not for training, but for testing. Now we will see that another one, granulated region-based CNN, which improves the performance both during training and testing. And what is RCNN? GRCN, it's basically an improved version of first RCNN, first RCSN. And here we incorporate the concept of spatio-temporal granules in a deep CNN model. So our basic structure is CNN, but here we consider spatio-temporal granules. In earlier one, it's not, just special granules. And I will show that it is an improved version of first and faster RCNN. And RCNN has a good name for 2 decades. So what is RCNN? So accordingly, it improves real-time detection speed and accuracy. Now, what is RCNN? It is basically 2-stage detector, object localization and class. So first, it makes an approximate localization of the region of the object, approximate, and then it goes for the classification boundary box. As a result, the perfection has increased, but competition is little higher. But now, since we have got GPU, that doesn't matter. So instead of using 1-stage object detector, which does not do any kind of region of approximation of the region of interest, directly goes by the classification. If you go by the 2-stage detector, have high localization and classification accuracy like this. That's why this is so important, RCNN. Now, what we do here, this is my RCNN, it's based on AlexNet. So I have taken the feature. This is a unique feature that we are considering video directly as input. In the earlier cases, earlier study, they consider frame by frame image. So here we have got F to F minus P frame. It's based on Alex architecture, that is 5 times repetition of CNN, pull 1, pull 2, ReLU, pull 2, convolution 2, convolution 3, pull 5. So here we use the spatial granulation, spatial temporal granulation. Temporal granulation, spatial color granulation. And we take the intersection here, we get spatial temporal granulation. And after this, in the pool map, we take the intersection of this granule over the map with pool 5 map. So this granule 2 interest. So when you take intersection means subset is resulting feature is less. And based on this, we get anchor generation, FTG formation, and then go to some metadata. So now, what we are basically gaining, number one, we take directly video as input rather than static images. That means it gives us spatial temporal granules for extracting ROI, which will be better than first RCN, faster RCN, because they do not consider temporal, spatial temporal anything. Second, only granules found over the pool 5 feature map instead of all features are in defining ROI. So here we are restricting, only we take the efficient ones, only granules found over the PI in defining, not any other, instead of defining one. And only positive ROI, that is, which have possibility of belonging to object, not to background, as decided here for classification task. While retraining Alexa, you see, this was built on AlexNet, which is a trained network. But since we are using granulation of this model, that trained network needs to be retrained. So retrain has some money, retraining. That I'll show. And you are taking only TG's selected FTG corresponding instead of the entire image frame. Only the FTG region corresponding instead of the entire feature map for performing object classification. Therefore, it gives real-time detection and speed performance. Let's see that one. This is a very recent, just it accepted, just got accepted last. So significance of granulation during training. These are my first RCNN, GRCNN, RPN. So AlexNet retrained with all my modifications and using static image I call RPN. If you take the video portion temporal, then I call it FRPN. So now let's consider here faster RCNN, AlexNet architecture, training image, spatial, etc. RPN, that is granulation, improves accuracy, mean average precision. So and here training time is more because it is because of the additional retraining of this model. You have the retraining of this model by additional component, that's why taking T. Similarly, if you take this GRCN, RPN and FRPN, 75 to 80%. Here again, it is taking more time because it does need a special component. Here we do not, temporal domain. Here we need only just special component. And because of this temporal domain, learning parameters, if you look at this, if you take only spatial, you go directly here. If you take temporal, you have this here, some money, and also you see the intersection. So these two. But again, during testing, this will be just superseded by others. But during training, it costs little money. That's why I'm saying during training one. Now let's come to detection results. The testing part. Testing part, let's consider first RCN, AlexNet. This is a training part of this. Static images, no video, just static. Image, test image, static image. Now look at this one. First RCN, 57.1, 65. GRCN, further input 79. So from here to here to here. Similarly, you take AlexNet by another training, more training, 61 to 63 to 88. So this means ROIs, which says detected by GRCN, are more representative of object classes. Now let's come to another comparison of spatial temporal versus spatial granulation. What is the advantage? Here I use the training data with both static image and the videos. This is videos. 19 UTRN and 19 these are videos. So when we train only with the spatial component, I call it RPN. When we train only with the spatial as well as temporal, I call it FRPN. Please keep it in mind. So now look at this scenario. When trained with all same training, this and this, same training, test data same, video data, 80.2 over 74.5. Take this one, 74, 76. And here speed also increased in spite of taking the temporal domain. Why? Because it is seen that the granules that you are forming, regions are forming, they are less but effective anchor for classification. And this drastically reduces the time in spite of using the additional one. This additional system, we had this one, additional. Because of this, we have this additional operation. If this additional operation during training, it costed money, but during testing, no. Testing, the way we are getting this one, their number is less and very efficient. Therefore, recursion score improved fast. So it is a supersedes Lecura. So now let's come to the evolution part. So now look at this. I started my talk about model granulation. Then it has so many applications for uncertainty modeling. Provided it depends how do you use the granulation and uncertainty measure. And I've shown the results just by doing lower and upper approximation, how to model even occlusion and under unsupervised condition. That means you do not have any prior knowledge. Then I'll explain the deep learning, the recent state of the art. Now look at this subject evolution. Pattern recognition subject was originated in 1960s. I started working in 75, 1st March when I joined Indian Statistical Institute. There was no book, no journal, nothing. Then artificial intelligence, machine learning experts appeared in 1980s when I was visiting Berkeley and other things. It is a buzzword, AI, machine learning. But that time AI did not survive much because we do not have data. Only by providing a course. In ISI also we provided a course on AI, but the number of students opting for that was getting low and low. And then knowledge-based system came in India. We had 5 based on the Japanese technology, Japanese concept, and we had in 5 knowledge-based center in India. One is ISI, one is TIFR Bombay, one is IIT Kanpur, University of Science, and CDAC Pune. 5-year UNDP project. Then data mining came in 2000 because of the internet, www and genome project, huge data. Then in big data came in 2010 because there was a survey for 2008 to 18 that there will be shortage of deep analytical scientists, about 45 to 50%. That's why this is one. Now we are talking about data-driven science, data science, data science, data science. Now the interesting thing is that new approaches for different tasks of pattern recognition. Here the mother subject is pattern recognition. It is we work in image processing, that is another portion, part of pattern recognition. See the new approaches for different tasks to handle varying nature of data. When we started in pattern recognition 70s, we had few hundred data for speech and 2 to 3 features only. That time, for finding the best feature, what we did, we clustered among the sample space so that the distance between clusters is maximum. And for which feature it was maximum, we just found those things. But today, it is other way. Today, the number of features is few thousand. The number of samples is only few hundreds or even tens. For example, you go to medical doctor or hospital only when you are sick. So they get the sample when you are sick only. On the other, if you look at the gene, RNA, there are few thousands. So here you cannot use those technologies what we developed before 80s. So then what we do, and most of those features, attributes, though they are large in numbers, but they are uncorrelated. They are uncorrelated. So if we can cluster around within this feature space instead of a sample space, then you can see that there will be nice some clusters. And if you can nice clusters, then take the centroid and forget other. If the centroid one, so out of few thousands, you can come down to few hundreds. So this is a highly cited paper for active transaction 2002. It's widely used for data mining for large data sets. So new approaches are coming up. There is a new terms and technologies are coined up. Initially we had the data mining, then we had big data, now we have got deep learning, data science. Now all over the country are giving data science course. You must have seen it. You must have also started, I don't know. I was involved in IIT Bhilai and IIT Jodhpur this course making problem. I am also mentor of IIT Jodhpur for this data science and machine learning group, forming research group there. So new terms are coming with a big hope. But there is a caution. Caution in the sense, don't jump into the subject. If you look at history, because machine learning means learning from examples, right? Learning from experience in one line, in machine learning. If you look at these 80s when we had neural networks, after 10 to 12 years, subject lost his interest because everybody jumped on the neural network. They expected too much. They thought that bank fraud identification, bank rate identification, in medical domain, everything can be sorted out by neural network. They didn't go in depth to neural network problem. That's why subject died. Here also I'm saying, if you want to understand data science, you have to understand deep learning today. If you want to understand deep learning, you have to understand shallow learning. If you want to understand shallow learning, you have to understand neural networks. If you want to understand neural networks, you have to understand pattern recognition. This is a basic thing. Then being image, you have to understand image processing. Video, you have to understand video technology and so on. But basic thing is that when you talk about deep learning, big data science, don't think that it will solve your all problems unless you solve the problem there. So don't jump into the subject. If you want to learn deep learning, data science, you have to learn machine learning, that is shallow learning first. If you want to learn shallow learning, you have to know neural networks. If you know neural networks, you have to understand pattern recognition. With this one, I conclude, and this is our latest book, just came out last week. I think, last week it appeared, 2021, Singapore, with my former PhD student, she's now the IT job book, Granular Video Computing with Deep Learning and IoT. And I acknowledge my students and your colleagues all over the world, wherever I work with them. I'm currently National Science Chair of the ACRB Government of India. And thank you very much, and please stay safe and keep well. Thank you very much.
Thank you, sir. Thank you so much for the enlightening talk. All of us are very fortunate to get an opportunity to hear you. Now, taking the event ahead, I would like to invite Vatsala to present a brief introduction to us about Anuvrat, the revamped Departmental Club of Electronics and Communication Engineering, NIT Sikkim.
Thank you, Ms. Anjali.
Should I now actually just stop sharing?
Yes, sir, you may stop sharing.
Yes, sir, you can. So if the participants are having any query, they are free to ask. Sir is here. Because one question is asked from the room that, sir, what is the present perspective of Faji in today's scenario?
Okay. See, Fuzzy theory is a 55-year-old subject, 65 it came, and 65 first paper. Every subject has its saturation level. Then it goes like just other topics. The beauty, if you look at the Fuzzy theory, that it is a non-parametric approach. That is, if the data that you have doesn't have well-defined distribution, or it is scanty, or it is heterogeneous, or it is incomplete, or it's vague, then Fuzzy is helpful in getting those information. That's the thing. So whenever there is a data science is considered, and every data has got ambiguity, every data has got overlapping concept, overlapping region, overlapping boundary, and therefore Fuzzy will be a good model to reflect those characteristics. And with rough Fuzzy theory, you can integrate neural network genetic algorithm upset in the name of soft computing. It is just in one or two sentences. If you want to know more, please ask me a specific question. Because it handles uncertainty arising from overlapping concept, vagueness, and so on. So every data has got an overlapping region, overlapping concept, or vagueness.
Thank you, sir. Thank you very much for this wonderful session. I hope there's lots of takeaway for the students. And we are also fortunate to have Professor Devatash Guha among us. Sir is Abdul Kalam Technology Innovation National Fellow and Professor in the Institute of Radio Physics and Electronics, University of Calcutta. So, Guha sir.
Hello, Shirajit.
Hi, sir.
Are you going to tell something?
Yeah.
No. I am not here to tell. I'm here to listen to great talk today. So I heard it from sir. So that's why I joined and I enjoyed this talk. And I remember our last year's event, and exactly the same day we had similar event at your very cold room.
Exactly so, sir. Yeah, we are also in the very same atmosphere today also.
Yes, I saw it is around 10 degrees centigrade right now.
Yes, sir.
So thank you, sir, for your nice presentation. I enjoyed it throughout from the very beginning.
Thank you very much. Thank you.
So very best wishes, Shirajit.
Yeah, thank you, sir. Thank you.
Thank you.
So, Vatsala, you can now start your session.
Thank you, sir. Now that you all know that we have chosen this particular occasion of National Science Day to ripe the seeds of Anuvrat that were sown deep down until now. As the reincarnation of the club has begun, I would like to introduce you all to the glorious past, to the enthusiastic present, and to the beaming future of this club. The necessity to extend the research and development activities due to fast-changing scenario in electronics and communication technology led to formation of an EC society at NIT Sikkim named Anuvrat. The club aims to provide young engineers a platform to put forward their ideas, innovations, and thought process to the world. The research interests of the club include major areas in electronics and communication engineering. The events in the past were guest lectures, simulation of circuits, circuit debugging, presentation on an allotted topic, science tools, and technical crosswords. Exhibitions had been organized to encourage competitive spirits among the students. Coding competitions were held to enhance the problem-solving abilities for the students. Now, as the club has decided to reinitiate the environment of enthusiasm toward technology and innovation, it is planning for exciting activities like alumni talk, workshops to provide a strategic and practical understanding, projects, HDL practices, expert lecture sessions, quizzes to test your knowledge of science and application of scientific principles, tech exhibitions to showcase and demonstration of projects, and study resources will be maintained through GitHub repositories. Doubt sessions will be organized, DIY projects on microcontrollers like Arduino, coding events relevant to ECE are organized, and case study on real-world problems for electronic students. Social media platforms for promotion, session on technological advancements in ECE, and club website is also maintained for a wider reach. The club has also renewed its website where it will provide the resources and ideas that will be budding in the young minds of NIT Sikkim. The resources will also be shared on the GitHub account of the club. The Anuvrat experience has begun with an environment rich in diversity, full of personal enrichment opportunities, brimming lights of new and enhanced knowledge activities. The students here will be provided with many opportunities to take part in a full schedule of events and activities that will impact them to become an efficient person. We are delighted to begin this new journey of the club and follow the path of greater achievements. Moving on to the next part of the event, the one for which all the students had been waiting for. As the future of STI has been chosen the theme for National Science Day 2021, so let's check that who are going to be the flag bearers of this revolution at NIT Sikkim. And what's a more fun than a quiz to test you all? So are you all excited for this quiz competition? No, you don't need to unmute yourself. All you need to do is to click on the link provided in the chat box and enter the game pin to start answering the mind-boggling questions. I request all the students to participate in this quiz. The participants are supposed to click on the link provided in the chat box. The participants watching on YouTube are also provided with the link in the chat box. I request all the students to enter the game pin and participate in the quiz competition. And they are requested to enter your name in the format provided in the chat box. And enjoy yourself.
Yeah, Anjali. Hello.
Yes, sir.
Is that a quiz session started or?
Yes, sir, it is started. Students are joining, sir.
So what we will be doing? We will be staying, or means how we will be organizing this session?
So the quiz will take just 5 minutes. After that, we can resume the presentation. We have a presentation on recent tech trends.
Okay.
But if you allow, we can present it now.
Yeah, I think the quiz session can run parallelly, so we can start the presentation.
Sure, sir.
Hello, am I audible?
Yes, Vatsala, go ahead.
Okay, yeah. Now that you all know that the club was established with a motive to provide a platform to young minds, so here we have Mr. Ronak Singh using this platform to express his ideas on smart footstep power generation technology. Ronak, the platform is yours. You can begin the presentation.
Hello, am I audible?
Yes, Rana, go ahead.
Yeah. First of all, thank you. A very justful evening to Honorable Director Sir, respected Chief Guest, all the esteemed Professor, and the entire fraternity of the institution. My name is Ronak Singh. I am a second year student and I am pursuing my BTech in Electronics and Communication Engineering. Today, technology have become the most important part of our daily lives. It is impossible to ignore its growth and development in present scenario. Today, we may not be living on Mars or traveling to work using jetpacks, but there is no doubt that the coming decade will bring many exciting technological advancements. Artificial intelligence and machine learning being one of them is increasing the ability of machines to learn and act intelligently and is absolutely transforming our world. Whereas robotic process automation is also catching up by automating jobs to a certain level of more accuracy than any human can provide. Edge computing and quantum computing are making computers multiple times faster and efficient in every aspect of multitasking. Virtual reality and augmented reality is creating a sensation around the world's market. It is also the driving force behind many of the other trends on the list, such as Internet of Things, which is also becoming a whole new era of technology to further extents. The new technology trend that follows the IoT is 5G. Everyone is talking about 5G in India, where 3G and 4G technologies have enabled us to browse the internet, to use data-driven services, increase bandwidth for streaming on Spotify or YouTube or internet, and so much more. 5G services are expected to revolutionize our lives. As technology is increasing, the demand for the energy is also increasing linearly. The demand of energy can be directly linked with the factor of increasing demand in electricity. Most of the technology uses electricity, and as it's fundamental for their use and it's fundamental fuel. And hence, the more user increases, it proportionally increases the problem of energy crisis. There are different possibilities and outcomes of such criteria, and hence, if you notice in the energy consumption graph, you can observe that many proportion of energy is generated from resources that cannot be renewed. And even if can be renewed, like sun or water or wind energy, if it can be renewed, we are extracting the energy in such a way that we are causing some harm to our environment. And there is no doubt that humans, no matter how advanced or carefully are advancing the method of energy extraction, they are still causing harm to the environment. So why not we use ourselves to generate the energy? Why not we use human? We always forgot that human is also a part of nature, and human also is natural resources. So why not we use human to create electricity? Well, the only power that is known and had been discovered is back in the 80s, where we can ride a bicycle just enough to light a bulb. And then we left the field of innovation because we started seeking comfort and we started seeking more natural resources and started extracting energy from them. And without our knowledge, and now we are starting to get the knowledge that we are creating numerous amount of problem, we are creating numerous amount of havoc in the world. So today, I'm presenting you with the smart foot step power generation technology. Well, you see, walking is the most common activity in day-to-day life. Walking, running, jumping around, anything. That is the most common activity a person is allowed to do. And when he walks, he loses energy to the road surface in the form of impact or vibration or sound or anything. And due to the transfer of his weight on the road surface, the foot falls on the ground during every steps, we are generating some amount of force. So why not we use that force to convert it into other form of energy? As we know, energy can neither be created nor be destroyed. So we can just transform one form of energy to another form of energy. So why not we create that force into electrical form? How cool that would be. I mean, think about you're sitting in an environment full of people or in an arena and the cricket match is going on and you're cheering and you're happy, you're jumping around, and there is a system where you can jump and create electricity. How good would that be for environment? We are not being selfish here and we can create electricity for our own use. So this technology is simply based on a principle called piezoelectric effect. In this effect, when we apply pressure to some certain materials, known as piezoelectric materials, it converts the applied pressure into electric voltage, specifically AC voltage. So let's understand the working principle of the piezoelectric material in details. So here in the circuit, you can see that when we apply pressure to the piezoelectric sensor, I already explained that piezoelectric sensor is a sensor which produce or convert the applied pressure into electrical voltage, and that also in AC voltage. So when we apply pressure to piezoelectric voltage, the AC voltage is produced, and then the AC voltage cannot be stored. As we know, like we cannot store AC voltage, so we need to convert into DC voltage, and that converting work is done by rectifier. So when we convert the AC voltage to DC voltage, then we need a storage facility. So the storage we acquire is capacitor or supercapacitor or any form of storage like battery or anything, so that it can be used later on. So this is a simple working circuit of the project. So when we advance the technology, there will be some advancement and there will be some critics. there will be some advantages of the technology, and there will be some amount of disadvantage of the technology. The advancement of the technology is, please change this now. Yeah. So the advancement is totally brought up by the paving system. It is a company, it is a technological company, and it has developed this paving slabs. It's just a simple circuit I have explained to you, the piezoelectric circuit, which converts the energy from people's footstep into small amount of electrical power. So what happens is they did a project on the basis of shoemaking, where they put the circuit inside a person's shoe, from which when a person walks, when the pressure is exerted, it is converted into small amount of electrical current, so that it can charge their essentials, it can charge their phone. Like when you go to a mountain climbing or hiking where there is no chance of getting electricity and you got stuck and you need some amount of replenishment into form of electrical power, then you can use this advancement, and it is really in handy. And I think it has started to being a trend since 2020, but due to the COVID pandemic, the work is delayed. So I have talked about the critiques as well, and the critiques is already mentioned. It only generates a small amount of electrical power. We cannot generate a large amount of electrical power from this. We haven't advanced it to this level that we can generate a long amount of power. But mention not, the paving system is already working in this field, and they are developing a microcontroller processed paving system, paving slab. The technology should have been come in 2021, but due to COVID pandemic again, it has been delayed, and they are working against it, and they are going to launch the project around 2023, and it is going to advance the technology to a certain level that it can power a huge amount of project. So I think the total conclusion from this project can be summed up from a small amount of words, and we can conclude that though we are advancing in numerous technology, and we are just focused about the advancement in technology, but we forgot about many different aspects of development and harm that we are causing developing this technology. I'm not saying that we should not focus on the advancement of the technology or that we should stop innovations, but if we are creating a technology and we are creating something new, then we should also concern ourselves about the energy consumption of our technology and try to solve it. There are 6 circles you can see in the presentation, that is technology, energy, environment, innovation, resources, and safety. If you can focus, it represents the broader perspective of development in every walks of life. When you are generating a technology, you should be aware of energy consumption, you should be aware that you are harming environment or not, you should be aware of innovation, you should be aware of your resources, and you should definitely be aware of your safety. So if we can conquer this barrier of development, if we can conquer these emerging trends, then those emerging trends will find new wings to fly through the horizon of the new era of development. So let's keep innovating and keep advancing, but also let's not only advance technology for mankind, rather advance it for the whole world. Thank you very much.
Thank you, Ronak, for introducing us to this innovation. And I hope that you must have inspired the other students to come and put forward their ideas and take advantage of this blazing platform. I hope that all other students must have also enjoyed the quiz competition, and it would have been fun with the tricky questions. Now heading to... Yes, sir?
Yeah, you may continue.
Yeah, no,
Yes, sir. Now, heading toward the end of this event, I request Mr. Deepak Chaudhary to finalize this occasion with a vote of thanks.
Thank you, Vatsala, for giving me this opportunity. Very warm evening to our Honorable Chief Guest, Professor Shankar Kumar Pal, our Honorable Director, Sir, Professor M.C. Govil, all the esteemed professors, the entire fraternity of the Institute, and all the graceful participants who spent their precious time gracing the occasion. I take this occurrence to thank the entire audience of the meeting. I am thankful to all the participants for their supports and the cooperation in making this event successful. A special mention to our Venerable Dr. Hemant Kumar Katania sir and Dr. Sujit Kundu sir for being the catalyst that inspired us to do our best and stand us as a pillar of power. It is not possible to thank everyone for such an appreciating involvement and the willingness they have expressed to finish the task. So finally, thanks to everyone for adorning the occasion and sharing their opinions today. Thank you.
Thank you very much, Deepak. Sir, Professor Shankarpal sir. Sir, we are very thankful for your time and the valuable lecture and knowledge you have shared with all of us. And so thank you, sir, for attending the session and delivering a beautiful lecture. So we are ending here.